now we're going to begin our introduction into logic. In 3.1, we're going to learn about statements, connectives, and quantifiers. We're really going to dig into what is the symbols that drive logic statements and how do we convert those symbols to words we can understand. So the first thing we have to understand is the term statement. A statement in logic is a declarative sentence, so it states a fact. And because it states a fact, either that fact is true or that fact is false. And so we represent a statement with a lowercase letter P, Q, or R. If I want to look at some examples of statements, remember it has to be true or false. So AIDS is a leading killer of women. I don't need to know if it's true or false. I just need to know if I can classify that statement as true or false, which I can. Oops, I went too far. If you eat less and exercise more, you will lose weight. Again, that has a true or a false. In the last 10 years, you've reduced by 25% green light gases. Again, true or false. Same thing with Garth Brooks and Taylor Swift. But the following are not statements. Come here is a command. It's not a declarative sentence, so it cannot be used as a statement. When did dinosaurs become extinct? This is a question, not a declarative sentence, so it cannot be considered a statement. And in G, our statement is false because it's a paradox. It can't be true and it can't be false. And so we kind of wind up at an impasse. Notice that A through D fall in two categories. They're either simple statements or they're compound statements that have a conjunction and between them. A simple statement is a simple sentence. It's a sentence that is one sentence with no conjunction. A compound statement would say and or, and it would have two statements combined using the conjunction. And the word that we're going to use for conjunction in logic is a connective. Connectives used with logic generally fall into 5 categories: negation, conjunction, disjunction, conditional, and biconditional. A negation is a statement where we express that something is not true. So the sky is not blue would be a negation, and what I would do is, in the actual logic statement, I would say not P would stand for the sky is not blue. Here's an example. If R is the retina display is included in the price of your MacBook, then the negation would be the retina display is not included in the price of your MacBook. And to write it in shorthand mathematically, we would just write not R. For B, the blue whale is the largest living creature. If I wanted to negate this, I would just add not into the statement, and then I would shorthand write it as not B. A conjunction, like we said, is and or, and it expresses the idea of combining two concepts or two statements. So the upside down V would be the conjunction and. So if I have the statement, the tenant pays utilities, and the statement, $150 deposit is required, then I want to combine those into one statement. And I would say it is not true that the tenant pays utilities and a $150 deposit is required. If I wrote that as a statement, since the first statement is a not, that would be not P. And then D, a $150 refund is required. That could be not D in English. What's the solution look like? It is not true that the tenant pays utilities and there's a deposit required. So that would be not P and D. For part B in the question that it asked me, the tenant does not pay utilities and a $150 deposit is not required. So how do we actually use this in problem solving? So in problem solving, we use the order principle, and we notice the difference in the form of the statements like we have in the diagram here. Statements can sound very similar to one another, but not actually say the same thing. Remember things like double negatives change the meaning of something. and it's really important for you to think slowly and completely through these problems. A disjunction would convey the idea of or, and it's written as an upright V. If I want to join ideas using or, so consider that I have these two statements, and I want to write this statement symbolically. We will not build, notice that's a not, more hybrid cars, or we will use more foreign oil. The first statement is negated, but not the second. And it's an or conjunction, which means it's going to be the upright V. A conditional expresses the notion of if-then when they use an arrow to represent a conditional. So ways of doing this and connecting ideas using if-then. Let's see what these look like. Suppose that P represents the Phillies win the World Series and M represents Mayhem will win an Emmy. If I want to write the statement as if-then, I would say if the Phillies win the World Series, then Mayhem will win an Emmy. Not necessarily true, but we did connect them using the right terms. If the Phillies do not win the World Series, then Mayhem will not win an Emmy, which would symbolically be not P, then not M. A biconditional is a special type of conditional phrase that represents the idea of if and only if. So if you dig really far back to your understanding of mathematics, you've probably heard a math teacher use that phrase a few times. If and only if is a highly accurate and specific way of communicating information. So if I have a polygon has three sides, if and only if it's a triangle, then if and only if is written with arrowheads on both sides of the statement. So I have statement P, statement T, and if and only if shows arrows in both directions. What about this one if I wrote a biconditional? The word not is in the second phrase, so it's going to be not that letter, and it is if and only if, which is this sideways arrow that goes both ways. Quantifiers tell us how many and fall into two categories: universal quantifiers and existential quantifiers. A universal quantifier would be a word like all and every, and so I have very definite frames of reference for all and every. An existential qualifier would be things like some, there exists, there is at least one, because it's ambiguous. If it's just some, well, how many is some? That's where we run into the question of an existential quantifier. If I want to negate quantifiers, then I have to be really careful. So if I look at this phrase I have here, suppose we want to negate the statement that all professional athletes are wealthy. So if you look at the two images, in the first image for part A, it shows that all athletes lie in the wealthy bubble. In B, I have some professional athletes that lie outside of that bubble. And it's true that not all athletes are wealthy. There are people on the lower strings. There are people who've blown their money. So it would be better to say some athletes are not wealthy than to do the entire piece. Here's another one. Some students will get a scholarship. If I want to negate that, the correct way to do that is no student will get a scholarship if it's a universal negation. If I want it to be some students will not get a scholarship, that becomes existential, and that would be incorrect. If you negate a statement with a quantifier, the phrase not all has to have the same meaning as at least one is not. It seems like that would be common sense, but it's important to make that distinction. So here's an example. All customers will get a free dessert, and some tablet computers have a 2-year warranty. I want to negate these. So if I'm looking at all customers will get a free dessert, to negate that I would say not all customers will get a free dessert. Because it has not all are, I could rewrite it as at least one is not getting dessert. Here I have some tablet computers, and if I'm wanting to negate that, I would say it is not true that some tablet computers have a 2-year warranty. Because this statement has not some have, I can then say none have in English. So no tablet computers have a 2-year warranty.